This morning in the Atlanta airport, no one's missing a meal on Mac Wilburn's watch.
With 11 restaurants to serve passengers, he's got dining for every destination.
And it all started when Mac talked with First Horizon Bank about opening a franchise in the airport. Now it's open for business and cleared for takeoff. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Mac. First Horizon Bank, member FDIC.
Hi there, thanks for joining us. This is Astronomy Daily. I am your host, Andrew Dunkley, and coming up on this edition, Mars may have been where life came from. That is an interesting concept. We also look at where our water may have come from, the sun's influence on water, as in the weather in the Pacific, and an asteroid hit on Canada. That's all coming up on this edition of Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.
As we welcome our AI reporter, Hallie. Hi, Hallie.
Hi, Andrew. I see that the World Cup has started. How do you think Australia will go?
Oh, Hallie, we got into the World Cup by the skin of our teeth, and our first game is against the defending champions, France. So how do you think we'll go? Then we play Tunisia, and then we've got Denmark. So if we make it to the second round, it will be a miracle. I'm not, talking us down. I'm just being realistic. On the plus side, though, we just won our 12th Rugby League World Cup last weekend.
Oh, okay. Rugby, right?
Well, this is where people overseas get confused. There are two forms of rugby: rugby league, which is the game I follow, and rugby union. So you're probably thinking rugby union, where they play the game a little bit differently. They look the same to the untrained eye, but rugby league has a 6-tackle rule, whereas rugby union, you can just keep the ball for as long as you can keep the ball. It's a bit confusing, but no, rugby league. We won the Rugby League World Cup for the 12th time. We beat Samoa.
I'll have to ask Siri to explain. I'm a bit confused.
Yep, that's what happens. All right, Siri, let's hear the news.
An international team of astronomers reports the discovery of two new super-Earth exoplanets orbiting a nearby late-type M dwarf star. The newfound alien worlds, designated LP899b and LP899c, are slightly larger than the Earth. The finding has been published in Astronomy and Astrophysics. Super-Earths are planets more massive than Earth but not exceeding the mass of Neptune. Now, astronomers led by Laetitia Delrez of the University of Liege in Belgium have discovered two new planets of the super-Earth class. They observed LP899, a nearby M dwarf star of M6V spectral type, using NASA's Transiting Exoplanet Survey satellite, TESS. This led to the discovery of the inner planet, which received designation LP899b. Follow-up observations of this system with the search for habitable planets eclipsing Ultraciool star's southern observatory resulted in the detection of a second longer period transiting planet LP899c. The astronomers underlined that their discovery makes LP899 the second coolest star found to host planets, after TRAPPIST-1. They added that LP899c is the second most favorable habitable zone terrestrial planet known so far. A relatively small, dense object cloaked within a cloud of its own exploded remains just a few thousand light-years away, is defying our understanding of stellar physics. By all accounts, it seems to be a neutron star, though it's an unusual one at that. At just 77% of the mass of the Sun, it's the lowest mass ever measured for an object of its kind. However, Viktor Doroshenko of Eberhard Karls University of Tübingen in Germany and his team were able to refine its radius to 10.4 kilometers, and its mass to an absolutely gobsmackingly low 0.77 solar masses, which means that it might not actually be a neutron star as we know it, but a hypothetical object not yet positively identified. According to theory, this strange star looks a lot like a neutron star, but contains a larger proportion of fundamental particles called strange quarks. It's challenging to ascertain how such a light neutron star could have formed under our current models. The team's research has been published in Nature Astronomy. Carrying out scientific experiments in space allows scientists to study and make drugs without gravity, which can lead to surprising results that improve research back on Earth. Competition for access to the ISS for this kind of research is gaining momentum as the ISS approaches the end of its life, while more commercial entities are expanding offerings in low Earth orbit, which could someday enable more common and affordable drug discovery and manufacture in space. The low-gravity environment on the International Space Station, ISS, can speed up the development and discovery of complex molecules used in medicines. Private companies, such as SpaceX, Northrop Grumman and Blue Origin, are building commercial stations to replace the ISS, and we could be seeing more experiments being performed in orbit with profound impacts on science back on Earth. And the U.S. Space Systems Command announced last week it signed an agreement with Blue Origin that could open doors for the company's New Glenn rocket to compete for national security launch contracts once it completes the required flight certification. This agreement paves the way for Blue Origin to compete for the next NSSL launch service competition, and is an example of how we foster competition and leverage industry innovation, according to Brigadier General Stephen Purdy, Program Executive Officer for Assured Access to Space. Having more competitors will help us meet an important national defense imperative to field advanced capabilities in space and get capabilities into the hands of our warfighters faster, he said. And that's the news, Andrew.
Okay, thanks, Hallie. We'll catch up with you soon. Now to an interesting story that suggests, not absolutely claiming, but suggesting that life in our solar system might have started on Mars rather than Earth. Now, the organic molecules that enabled life to emerge were present on Mars around 4.5 billion years ago, according to new research. And while these components may have hitched a ride to Earth around the same time, it was on Mars that life found the most hospitable conditions. Interesting. Earth and Mars are both members of the inner solar system, which is made up of 4 rocky planets in the asteroid belt. And shortly after their formation, these planets were brutally bombarded by a torrent of asteroids, which rained down on the inner solar system. And these rocks became assimilated into the crust of both Earth and Mars. But because of the tectonics on Earth, a lot of these meteors were recycled into the planet's interior. But it wasn't the same on Mars. The surface of Mars was stationary, which meant the rocks that smashed into the planet in the distant past remained in place so they could be studied. And they've looked at 31 of them. The authors of this study were looking for answers to a series of fundamental questions about their origin. For example, until now, scientists had never determined whether these ancient projectiles came from the inner or outer solar system, or whether they carried any of the organic material that could have led to the development of life. So they used ultra-high precision chromium isotope measurements, and the researchers identified the meteorites as carbonaceous chondrites from the outer solar system. And based on the prevalence of such rocks on Mars and the fact that ice usually accounts for 10% of their mass, the authors calculated that these ancient impacts brought enough water to Mars to cover the entire planet in 307 metres or 1,007 feet of water. That is quite a stunning claim. Significantly, these chondrites from the outer solar system are also known to have transported organic molecules such as amino acids to the inner solar system. Those are the compounds essential for the formation of DNA and are likely to have provided the raw materials that allowed life to emerge. And because of the situation that they're claiming, that Earth was too volatile for life to start here from direct impacts, it's probable that the life that developed on Mars transferred to Earth, or at least the raw products to create it. That is a really interesting theory, and it probably holds a lot of water. Boom, boom. The study is published in the journal Science Advances.
The Astronomy Daily Podcast
with Andrew Dunkley.
Speaking of meteorites, an ancient meteorite that crash-landed in the UK, in fact it landed on someone's driveway, may have solved the mystery of where Earth's water came from. It's a 4.6 billion-year-old space rock. It landed in the front yard of a family home in the English town of Winchcombe in February last year. It contains water that closely resembles the chemical composition of water found on Earth, and that presents a possible explanation of how our planet was seeded with the life-giving substance. When the rocky inner planets of the young solar system first coalesced, clotting from hot clouds of gas and dust billowing near the sun, they were too close to our star for oceans to form. In fact, past a certain point called the frost line, no ice could escape evaporation, making a young Earth fairly barren. Scientists think this changed after Earth cooled, when a barrage of icy asteroids from the outer solar system brought frozen water to our planet to melt. Now, a new analysis of the Winchcombe meteorite published last week in the journal Science Advances has added significant weight to the theory. So it's got to have come from somewhere, and that one sounds like it also holds water. How many times can I use that pun? Well, here's another story about water. Weather and climate modellers understand pretty well how seasonal winds and ocean currents affect what's called the El Niño pattern in the Pacific Ocean, which impacts the weather across the United States and also the Western Pacific. And the El Niño has been acting up in recent times. Right now, we've got the opposing system affecting weather in Australia called the La Nina, so very, very wet, while the El Niño causes droughts, which people in America, the west coast of America, certainly have been experiencing. New computer simulations have shown that one driver of annual weather cycles in the Pacific region, in particular, a cold tongue of surface water stretching westwards along the equator from the coast of South America has gone unrecognised. And it's got something to do with the changing distance between the Earth and the Sun. The Earth-Sun distance slowly varies over the course of a year because Earth's orbit is slightly elliptical. And currently at its closest approach, perihelion, Earth is about 3 million miles closer to the Sun than its furthest point. As a result, sunlight is about 7% more intense at perihelion, and according to research led by the University of California, Berkeley, it demonstrates that the slight yearly change in our distance from the Sun can have a large effect on the annual cycle of the cold tongue. This is distinct from the effect of the Earth's axial tilt on the seasons, which is currently understood to cause the annual cycle of the cold tongue. And because the period of the annual cycle arising from the tilt and distance effects are slightly different, their combined effects vary over time, according to John Chiang, a professor in geography. He noted that the distance effects are already incorporated into climate models, though its effect on the equatorial Pacific was not recognised until now, and his findings will not alter weather predictions or climate projections. It's just something that popped up. The distance effect and its 22,000-year variation also may affect other weather systems on Earth. And finally, it's an asteroid kind of day today. Astronomers have spotted an asteroid just hours before it hit Earth on the morning of November 19th near Lake Erie in Canada. It's not the first time this year astronomers have discovered a rock from space just before it made a direct hit. But this time it entered Earth's atmosphere over a populated area crossing the skies of Toronto. So there's a lot of video and eyewitness accounts. Ye Kwangji, a University of Maryland astronomer who studies asteroids, comets and meteors, reported on Twitter that it looks like a space rock is going to fall into Lake Erie in about 2 hours. And that's exactly what happened. He shared the link for NASA's Center for Near-Earth Object Studies Hazard Assessment page. The object C8FF042 is now removed from the page because it struck Earth and is therefore no longer a threat. Thankfully, it didn't hit anything precious or important, although Lake Erie is fairly important, I imagine. Anyway, now, if you want to chase up those stories, you can jump onto our new URL, astronomydaily.io, and read more about what we were talking about today. You can also subscribe to the newsletter, which will be delivered to your inbox daily, free of charge. And you can catch up with the latest edition of Space Nuts while you're at it at spacenuts.io. And don't forget to leave your reviews of Astronomy Daily and Space Nuts via your favourite podcasting platform. And Hallie, anything before we go?
I was talking to Siri about rugby, and I have a question.
Yeah, shoot.
What's the scrum all about?
Oh. It would probably be easier if I explained the LBW rule in cricket, but let me try. In rugby union, the scrum is a tactical manoeuvre and you use your strength to push the other team back and sometimes roll the ball over the line into what the Americans call the end zone to score. It's a way of also getting a penalty against the other team if you can force them to collapse the scrum or rotate off centre or something like that. In rugby league, it used to be something similar, but they've changed the rules and now they just do it because they can't think of another way of restarting the game. So, does that answer your question?
No. And what's LBW?
That's a discussion for another day. Bye, Hallie.
Bye.
Until next time, this has been Andrew Dunkley for Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.